Hey everyone, we're going to go over radians and degrees, and I'm going to talk about the unit circle in this lesson. So the definition of a radian, it begins with the concept of how do we associate like something other than degrees, dealing with degrees, and that's all that we've been working with. But it's actually helpful to consider a different thing, which is associating the central angle. And the central angle is just from the center out to a point. So here's a central angle. The central angle here is 90 degrees, okay? So, and we're associating that central angle of a circle with the arc it intercepts. So here is the arc right here. So the arc, and arc, it stands for, it's the length of that. Okay, so when you hear arc, you can think length. Looks like an E. Okay, so when we're trying to set this up, we can begin by saying, okay, well, do you remember from geometry that circumference is equal to 2 pi r? So what happens if you take 1/4 of your circumference? What does that mean? What does that represent? That is the arc length, 1/4 of the way around the circle. So that's this length, okay, from A to B on the edge of the circle. And if we just substitute the 1/4 in and put it into our formula, 2 pi r, this 2 cancels out, so you're at pi over 2 r. Okay, so that is equivalent to, we could say 90 degrees is equivalent to pi over 2, and we use radians. You could, going back to it, they came up with the word radians, but in a sense it's pi over 2, and it says this in the book, which I like the description. Radiuses, you could say, right? But that doesn't really sound right. So, or radii, I think that's plural. If it is Latin, we can add that. So something like this, the radii, the radiuses, it's really just pi over 2 radians. Now, it's really strange, and I think this is just finally sinking in with me, so I can't imagine if you're just first getting into radians, but we're not talking about like a measuring of a degree. We're talking about the outer edge of a circle when we think about radians, right? And we're associating that. But remember, it always corresponds. So if you looked at, let's just try it. If we did this equivalent of 45 degrees, well, 45 degrees, if I break this circle up, 1, 2, how many pieces in the pie is that? 2, 3, 4, 5. So that's 8 pieces of the pie. So it's 1/8. This length right here, this arc length, is 1/8 of 2 pi r. So this 2 goes into 8 4 times. So this is pi over 4 radians. All right, and then you can see with the 180 degrees, if you take 1/2 of the circumference, that's equivalent to pi radians, pi r. And then all the way around, 360, that is the entire way. So 2 pi is going the entire direction, or entire circumference. So if you say 360 degrees, that is equivalent to 2 pi radians. Pretty cool thing. The reason why radians are so convenient at times, it's because the number is smaller. So in our calculator, if we calculate that, and let's just figure that out, we'll turn on pi. So we know that pi, the distance, like from, in this case, this length is a direction of pi radians, right, from here to here. So if we enter pi, we know that that's 3.14, right, or approximately 3.14. So the entire distance around, 2 times pi, you don't even need to do the times, you can just write 2 pi is 6.238. So, you know, if you approximate that, that's 6.238. So this versus 360 degrees, right, is a smaller number and nicer to work with, and you'll appreciate it when we're graphing these functions. And we can use a scale that's a lot smaller, 6.238. The other point where you use radians is, and the book pointed this out, there's a lot of applications that actually just deal with arc length versus degrees. So knowing your arc length and dealing with trig functions is very convenient at times. Since I've got the calculator up, just remember if you now we've been in degree mode this entire time. You're in degree mode for all of the right triangles and all of the applications that we've done so far. So you go into mode and then you scroll down to radians, you hit enter, and then once you're in radian mode you can quit. Okay, so just for fun, the sine of 90 degrees, and that's, remember, at the top of our circle, is 0.8939. If you did this, since we're in radians, now we have to do it the sine. Do you remember what 90 degrees is in terms of radians? That is pi over 2. So here we go. Pi divided by 2 is equal to 1. And that is the correct answer. If I change this and went down into degrees, and I went back to the sine of 90 degrees, that should also be 1. Okay, so the sine of pi over 2 is equal to the sine of 90. They're representing the same thing. Pi over 2 is representing arc length of the circle, and sine of 90 is representing degrees of the circle, whatever your central angle is. So it's given this is what we were talking about, that 360 degrees is equivalent to 2 pi radians. And we can derive formula 4.2 by starting off with the fact that 360 degrees is equivalent to 2 pi radians. And what I'm going to do is I'm going to divide both sides by 360. I'm not taking the degrees with me. And that cancels out. So I have degrees, just abbreviate that, it's equal to pi over 180 radians. Now if I just tack on, multiply both sides of the equation by x, I have x degrees is equal to pi over 180, you can put the x here or wherever you want, radians. Okay, so for example, if you said, all right, x is equal to 90 degrees, we want to convert to radians. So you say, okay, we've got 90 degrees times pi over 180, right? And that is equivalent to whatever your x value is in degrees. Okay, so these degrees, and let me write the radians. You don't have to do all of the units every time. I just want to show you that it does work and they all cancel out. So see how the degrees cancel out on both sides because you can divide out the degrees. So x is equivalent, because they're 90 degrees is also equivalent to pi over 2 radians. So just so you know, you're not going to spell out radians every time. It's assumed that if you have something like, or if you come across cosine of pi over 2 and they ask you to calculate that, assume that the mode that you need to be in and think about is radians, because anytime you see a pi, if you see a pi symbol, think radians, okay? And look for the degree. It's not always there, like sine of, we don't always write 90 degrees, but that's most likely, rather than 90 radians, which would be a few rotations around the circle. Sine of 90 is most likely, the mode would be degree mode. So let's derive the other. So now we've got that 360 degrees is equivalent to 2 pi radians. Let's just say rad. So if we divide both sides by 2 pi, well, once we simplify, and then we've got, let's see, what is that? 180, just what it was, only the reciprocal, and that's in degrees, is equal to radians, and then we'll put in a x on both sides. Okay, so if I wanted to convert something from, let's see, let's do some kind of different one. Let's do pi over 3, and you can kind of guess what's a third. If you know that pi is to 180 degrees, just think about that. What is a third of 180 degrees? Because that would give you your answer too. But we'll just do it using the formula, and this is formula 4.2 that we are deriving, and you can look at that. But we just plug it in, so we've got, and we know that this is in radians, right? So if I plug in my x, that's pi over 3, and I should write on it so you guys see, convert this into degrees. So we've got pi over 3 radians times 180 over pi degrees is equal to x radians. So my x, or my radians, conveniently cancel out, and the pi's conveniently cancel out. And if the pi's don't cancel out, then you probably haven't converted into degrees properly. So look at this. This is degrees, right? Equals x. And what did I say up here? It's like pi is to 180. So then if you are a third of the way there, that's dividing it by 3. So that would be 60 degrees is x. So x is the same thing. X is equal to pi over 3 radians, or x can be equal to 60 degrees. This is a degree measure. This is measuring the angle. This is measuring the outside edge of the central angle that's subtended, which just means it creates that arc, that particular arc. Okay, so this is the given formula, right? You've got degrees to radians, radians to degrees. I'm not going to allow this on an exam, so I hate memorizing formulas, and I never would remember, is pi go on the top, 180. I don't know, it's not that big of a deal, but you guys can choose to memorize this and this, or you can do it my way, my crazy way. So the way that I like to do it, because I just think about, I think setting up a proportion makes more sense to me. So if we convert 250 degrees to radians, I say 250 is equivalent to 360 degrees. So we can cancel out the degrees as whatever that angle is that we're looking for, theta, is to 2 pi. And we can say that that's in radians. All right? So the degrees cancel out. We can simplify this, 25 over 36. Don't think that's necessarily a nice fraction, but you just solve with that. I'm going to solve for theta. Whoops, not empty set, theta. So if I get theta by itself, I have theta radians is equal to 2 times 250 over 360, and I've got a pi out there, okay, because I brought the 2 pi over to the other side. I don't know, maybe this isn't the best way, but I like it. So then you have 25 over 18 pi, so that's 25 18ths pi. I don't think we can simplify that anymore, but that is, and then if you wanted to tack on the radians, sorry about that. But usually I don't really mind if you don't. For this lesson though, for 4.1, do tack on the radians just so you get used to it. But we won't always write radians, because if you see the pi, like I said, you'll understand that it's radians. So I would say that 250 degrees is equivalent to 25 over 18 pi radians. Now, if we plugged it into the formula and we wanted to go from degrees to radians, we could use 4.2 and just plug it in. So maybe I'll do that right now just to show you that it's equivalent. So we have, and maybe you like this way better. It could be the better method, but I think this also, these proportions help when we're doing arc length and areas of sectors, just thinking about that rather than memorizing formulas again. So get used to it. So we've got, if we're going from, we want to convert it to radians, so we say pi over 180 times 250. You see that we've got this simplified here, so if I Simplify that, cancel out those, and we're left with 25 over 18 pi. You're probably shaking your head right now and saying, oh, that was so much easier. I guess if you happen to blank on the formula, this is another alternative. I don't know why I like it, I just do. I guess because I like math so much, right? So then if we did this one, now you're going to scoff because this might get a little ugly. I'd say negative 5 over 2 is to 2 pi, because now we're dealing with radians, as whatever theta is to 360 degrees. Okay, so I know that my outcome, my answer is going to be in degree mode. So you could just put a degree on that side. You solve for theta. So theta is equal to 360 times the top, which is negative 5 pi over 2, and that's all over 2 pi. So I could cancel that. That's 180. I could cancel this 2 into that. That's 90. I could cancel these pi's. My answer is going to be 90 times 5, which is 450, and it's negative 450. Yeah, so negative 450 degrees. All right, so if you think about that, I just, as a refresher, remember this is negative, so we're going from the x-axis and we're going around. But negative 5 pi over 2 is also equal to negative 2.5 pi. So remember, 2 pi is all the way around, and then you have another half of a pi, so plus half pi, so that lands you right here in this direction. 450, if we think about that, negative 450, 360, now I have to do math on the spot here. This is 360, and then if I add, what would that be? 360, just to check that out, plus 450, I need 90 more degrees. Oh yeah, I messed up. You have to go, if you have pi over 2, sorry, pi over 2, this would be pi over 4, what I put. This is pi over 2. So I went all the way around 2 pi plus pi over 2, that lands me here. I went all the way around, that's 360 degrees, plus 90 more degrees, that lands me at 450. Teachable moment sometimes when you make mistakes. So I like this picture here. I wanted to talk about it. It says, formally, a radian is defined as the central angle in a circle of radius r which intercepts an arc length of r. So that's the formal definition. I like to think about it. Yeah, this is the arc length of r. This is the radius of r. So at the point where the arc length is equivalent and equal to the radius, that is 1 radian. Okay, so 1 radian, and if you convert that, is equivalent to 180 over pi, which is approximately 57.3 degrees. Not something that I expect you to memorize, but 1 radian, remember, is the length. And it, like it said in the book, it doesn't matter what your radius is. It could be a bigger circle, right? And it's always scaled because this is r, and then you can see that that length right here would be about r. Doesn't that look about like 57 degrees? That's also equivalent to, approximately, we should say, 57.3. Doesn't that look like 1 radian, kind of? Okay. Okay, so here's a chart of common degrees and radians and the equivalent to that. So in this case, I like to think, and we're going to start looking at the unit circle, so I'll tell you about that in a second. But just remember that we've been talking about the XY plane, and we've defined theta to be any angle in there. So it could go from 0 to whatever. Remember, it starts on this side. So if you're looking at pi, you know that the distance from here, which is equivalent to 0 degrees, this is 180 degrees, right? This is also 0 for radians, and it's equivalent to pi for 0 for degrees, I should say, and 0 for radians. But this is over here, this is pi radians. This is also equivalent all the way around. If I make it back, it's also equivalent to 2 pi radians, and as in degrees, it's equivalent to 360 degrees. So what I do is this is like a lesson in fractions on breaking down this circle. So you have 180 degrees, right? You break it down in half, that lands you at 90 degrees. And then think about what's half of pi. Half of pi is pi over 2, okay? So then what if you break this 180 degrees into 4 pieces? Well, that lands you here at 45 degrees. And then 45 and 90, that's 90 degrees, and then 90 plus 45 more degrees, that's 135 degrees. 135 plus 45, you can check my math, that's 180. So that's equivalent if I go, okay, that's a quarter. See how it's broken up? Pi is broken up into 4 equal pieces, right? So this is pi over 4, right? This right here is, we could say it's 2 pi over 4, right, on the top. Let's get some different colors in here so it's easier to see. So this is 2 pi over 4, but what does that simplify to? That simplifies to pi over 2. This is 3 pi over 4. That doesn't simplify. And this is 4 pi over 4, which is equal to pi. This right here is 5 pi over 4, because now we're at pi, and if you converted that to a mixed number, it'd be 1 1/4 pi, right? 1 pi is right here. We're over here at 1 1/4. This would be 6 pi over 4, but what does that simplify to? 3/2 pi. And then this is 7 pi over 4, and this right here is back to 8 pi over 4. What does 8 pi over 4 simplify to? It simplifies to 2 pi. Okay, you can do the same to figure out what its equivalent is. So you can go 45, 90, 135, 180. We already did that. What's 180 plus 45? And I could make a mistake on my math. No, I should know this. So that would be 225 degrees. Another 45. We'll see if I make it all the way around. Then I know that I've done okay. So that would be 270 degrees. If I go here to this, 270 degrees plus another 45 degrees, that lands me at 305 degrees. And then if I add 45 more degrees, right? No, it's 315, right? I did some bad math. 315. That would make more sense. I was doing that in my head. So if I add 300 or 45 more degrees to 315, I get back up to 360. Do you see what I'm saying here? So if we break this down even more, we did pi over 2 up here. We've got 2 pi over 2, right? If I just break the circle into all the way to pi in just to 2 equal parts, that's 1 pi over 2. This is 2 pi over 2. This is 3 pi over 2, which we already have. And this is 4 pi over 2. 4 pi over 2 is equivalent to 2 pi. Okay, now what if I broke up pi into 8 equal pieces? Here's 1, so that's pi over 8. Here's 2 pi over 8, which is pi over 4. Here's 3 pi over 8. Right? This is 4 pi over 8. That's pi over 2. It should be. This is 5 pi over 8. 6 pi over 8, which is 3 pi over 4. And this is 7 pi over 8. Okay, so that's just another way to think about it. What is an eighth of 180? 180 broken up into 8 equal pieces if we think about degrees. 8 goes in, that's 2. Can't see that very well, can you? 20. So that's not even a nice one, right? 8, 20, that's 16, that's 40. So it's 20 point, if I did, let's see, my math right. 20.5. Okay, so if we do break it up in that, which I shouldn't have even done this one because it's not the nicest number, but that's kind of a little lesson with, it's actually 22.5. That's a nice little lesson with kind of fractions. So pi over 8 is equivalent to 22.5. Okay, and you can kind of see that in the unit conversion in those formulas. You're dividing by, or 180 dividing by the number of parts there. Okay, so then this the next pi over 8, 45 should be 22.5 plus 22.5. That's 45. Okay, we did pi over 4s, all of the pi over 4s. What if we did pi over 6 and broke it up into 6 equal pieces? So once again, you have pi over 6. All right, so that would be a little bigger than pi over 8. Pi over 6 is a little nicer because if you divide 180 into 6 equal pieces, that's equivalent to 30 degrees. So here we go. Here's 30 degrees, and that's pi over 6. That's 1 pi over 6, 2 pi over 6. So that's another 60 degrees. Okay, 3 pi over 6, that's another 90 degrees. So let's see, 3 pi over 8. The 3 pi over 8 is throwing me off. We'll go into the unit circle and we'll make a nicer chart. That's coming up next. So I like the way that Michael Corral, he's the author of this textbook, how he doesn't actually go straight to the unit circle. A lot of textbooks in trig do that right away. And I think the right triangle trigonometry has so many applications and other than just unit circles and radians. So, but I do think that it's nice to talk about. I kind of mentioned it, and I know that you guys may have heard of it from other classes. The unit circle, and I've mentioned this before, is just a nice circle to work with. The unit circle, we assume that it has a radius of 1. Okay, so in this case, if I just, in the xy plane, remember this is the x-axis, we could say this is the y-axis. So this point is 1, 0, because from the center out to this point, it's 1. It's a length of 1. This is negative 1, 0. This is 0, 1. And this point right here is 0, negative 1. So to find the other, we can use right triangle, the idea of right triangles and 30, 60, 90 triangles. So this distance right here is, and I won't do it for all of them, but this right here is a 30, 60, 90 that we can create. Okay, and we could say that just for practice, so this is equivalent to 30 degrees, and in terms of radians, if I break that up, do you remember from the last, this is also pi over 6 radians, okay, because if you do 180 divided by 30, you're going to get, that goes in 6 equal times, so I'm going to break up pi into 6 equal parts, okay? So this is pi over 6. This is 2 pi over 6, back to that idea, which is also pi over 3, okay? So we'll talk about that in a little bit. But let's go back to this triangle. You can always drop a perpendicular down to the x-axis, and you can draw this. Now, a 30, we said, and I've done this example before, I think I'll do the work over on the side because it'll get too messy in there. So this length is 1 because that was the radius. This is my 30 degree, here's my right angle, here's 60. So if this is 1, in a 30, 60, 90, it goes like this. Here's 2x, this side is x, and this side is x root 3 because it's opposite the 60 degree angle. So to find x, we say 2x is equal to 1. That tells me that x is equal to 1/2. So this height right here is 1/2, and this length right here is root 3 over 2. So because if you plug in x here and the 1/2, you get root 3 over 2. So if I put a point right here, and let's change the colors. If I put a point right here, I would say that how far over from the origin am I going? This is just a point in the xy plane. I'm going root 3 over 2 units, okay? How far up am I going? I'm going up 1/2. All right? Now, the other convenience for doing the unit circle is if I say, okay, find cosine of 30. Cosine of 30 is equal to, we know from earlier, x over r. What is r in the unit circle? R equals 1. What is x from this point? It's equal to root 3 over 2. So we could say that the cosine of 30 is equal to the square root of 3 over 2. And also keep in mind that the cosine of pi over 6 is also equal to root 3 over 2. This is in degree mode. This is in radian mode. Okay? So the convenience of it is that cosine of an angle with the unit circle goes with the x, and you don't need to say it's over r, and sine of an angle goes with whatever the y is. Keep in mind, these are locations in the xy plane, okay? This is where this point is. Could I do another point along here? If I extended this, yes. Remember, these are ratios. So these ratios always simplify to one given thing. So you can simplify it down to the unit circles idea, because r, when r is equal to 1, we've got a very nice simplified version. Okay? And you can derive the next one, and I might have that as an assignment later. So this, the 45-degree angle, right here, if I dropped a perpendicular, so let's find that second point. So I know that this is 45, this is a 45, if you recall that. And so excuse the sloppiness in my drawing program. On this side, I had to edit it, and I tried to clear it, and it just didn't work so well. So we'll get a new screen soon. But on a 45, 45, 90 triangle, we've got that the two sides are x. So here's x, this is x, and then this side is x root 2. So if I say, okay, I'm given that x root 2 is equal to 1 because that's the radius, x is equal to 1 over the square root of 2, and if I rationalize that denominator, I can multiply the top and the bottom by root 2 over 2, and I think it's easier to work with that. So root 2 over root 2, is multiply. So now root 2 over root 2, that tells me from my triangle, because those are the sides. So this length is equal to root 2 over 2. So I'm really going over square root 2 over 2 units in the xy plane, and now I'm going up. And those should be equal, right? It's a hypotenuse, or it's an isosceles triangle, so root 2 over 2 right here. So if I asked you then what the tangent of 45 degrees is, and you should know that that's 1, but this is another reason, and we've done this before, but I just want to get it in your heads. Root 2 over 2 over, because it's y over x, which is equivalent to 1, okay? Because you're going over the same amount as going up, so this ratio is going to be equivalent to 1, okay? That's also the tangent of pi over 4, right? So tangent of pi over 4, if you are in radian mode in your calculator, you put that, you should get a 1. So let's fill in some points here. So we've got this point is at 1, 0. This point is at negative 1, 0. And I think on the next exam, I'm going to give you a blank unit circle, and I'm going to expect you guys to fill it out, okay? Here is 0, 1. We just found that the 30 degree, so you can say that this is 30 degrees, or that's also equivalent to pi over 6. So this point is at, we're going over, it's longer in length, and that's root 3 over 2, and then we're going up by a half. This next one is 45 degrees, and that's also equivalent in radians to pi over 4. So this point is, we just found from the last example, root 2 over 2, root 2 over 2. Now remember, this is a cosine, this is the cosine of your angle, this is the sine of your angle, and that's always true, okay, which is pretty convenient. This, the ratio, cosine from identities over sine would be the cotangent of that angle, right? So what would the cotangent of 30 degrees be? Well, that would be cosine, which is root 3 over 2 over 1 half. So the cotangent is equivalent to, the 2's cancel out, root 3. The cotangent of 30 degrees equals root 3. The cotangent also of pi over 6 equals the square root of 3. That's the exact value. So exact values are really important in math, not approximate. So you're going to have to be able to do that. Now if we draw this triangle, and let's get a different color, and I drop down this perpendicular here. Now this is a 60 degree, so here's my 60, here is my 30 degree. So basically everything from here gets flip-flopped, okay? So now I'm going over 1 half, this is how I remember it, because it's just these, but it's switched. Now this is 1 half, and this is square root 3 over 2. Okay, so that is a kind of nice and convenient thing to deal with. This point is 0, 1. So remember, if I ask you what the sine of pi over 2 is, because that's halfway here from pi, that's equivalent to 1. What about the tangent of pi over 2? Remember what that is? That's y over x. Do you see why that's undefined? That'll come in handy when we're graphing because that's going to be a vertical asymptote at pi over 2. So you can fill in the rest of the unit circle by symmetry. This point over here is going to be the same as this point, right? Only this is negative 1/2 and I'm going up square root 3 over 2 units. All right, so this is something to think about in this case. So we've got pi over 3. This is 2 pi over 3, right? So I would say 2 pi over 3, or we could say that's 30. No, that's not 2 pi over 3. Yes, it is. Sorry. So we've got 30, um, 60. That's the problem. I kept looking at this 30, getting confused. So we've got 60 degrees, and then I skip over 60 more degrees. This is also 120 degrees. That's what's going on. And then if I go 60 more degrees, that lands me at 180 degrees, or pi radians. This is 2 pi radians, or 360 degrees, or 0 degrees. They're all equivalent. So in this case, if I say, okay, do you see how the sine of 2 pi over 3 is equal to root 3 over 2, just like the sine of pi over 3 is equal to root 3 over 2. Okay? In cosine, in this case, they're opposite signs. So the cosine, and do you see where all those identities may have come from? The cosine of 2 pi over 3 is equal to negative 1/2, but the cosine of pi over 3 is equal to positive 1/2. All right? So really you have to memorize these with root 3 over 2, 1/2, root 2 over 2. Just remember that in the first triangle, or this first angle, I'm going farther over on the x and up by 1/2. Root 3 over 2 is is larger than 1/2, so you're going over root 3 over 2 and up 1/2. So then this is 1 pi over 4, 2 pi over 4, 3 pi over 4, okay, or 45, 90, 135 degrees, okay? And I know that I'm going over negative root 2 over 2, root 2 over 2. And it's getting sloppy. You can always look at the Google unit circle and find an image, and it's really easy if you need something to study from. And so then this one, flip-flop this, so I'm going over negative root 3 over 2 and up 1/2. This already is negative 1, 0. This one, this point right here, if I'm going, oh, and I didn't identify that, pi over 6, 1 pi over 6, 2 pi over 6, right? 3 pi over 6, 4 pi over 6, 5 pi over 6, okay? Or 30, 60, 90, 120, 150, 150 degrees, right? Because we're going by degrees. So you know what I'm just thinking? I want you guys as an assignment, and I'll put a blank sheet up on Blackboard. This is great. I want you guys to fill in the rest using this kind of terminology and see if you understand it. So I'll put this on Blackboard, and you can copy it out. You can draw it if you want to. It's nice to have this template though. And then and fill it in. That's part of your homework assignment for this lesson. And that's all she wrote. Have a great weekend. And I think you'll be excited that we're moving on from identities. Although we'll come back eventually just to practice, but this stuff is starting to get really interesting, and I think you'll like radians and degrees and arc lengths and graphs of trig functions.